Good morning, class. Here's chapter 2 review, limits and derivatives, exam 1 covering 2.1 to 2.8. And here's the part covering 2.7, derivatives and rates of change. 2.8, the derivatives as a function. So 2.7, derivatives and rates of change. Given y equals f of x and point P having coordinates a comma f of a, point P having coordinates a comma f of a. The slope of a secant line PQ. So pick another point, connect them. The blue line is called the secant line, is average rate of change, the good old slope. So M, the slope of PQ, is rise over run delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1, as we have seen it before. If we go with what we see here is change in y is f of x minus f of a. Change in x is x minus a, in other words, rise over run. The point being, this is one way to write it, this is another way, this is another. Now, if we have a f of a and this one, we go a distance of h. So a, this becomes a plus h. So the rise would be f of a plus h minus f of a, and the run would be a plus h minus a, which is h, becomes f of a plus h minus f of a over h. This is another way of writing the same thing, slope of a line given 2 points. Now, if you call this pair b f of b now, it's f of b minus f of a over b minus a. They all giving us the same thing, rise over. Now, you have 2 points. You have the secant line. And as you move the second point Q closer and closer to P, gives rise to the red line, which is the tangent line. So the tangent line is the limiting position of the secant line PQ as Q approaches P. A tangent line is a line that touches a curve at a specific point without crossing it. Slope of a tangent line, also known as instantaneous rate of change, M of tangent line, it's the limit of M of PQ as Q approaches P. So we have this. Now we move things around such that Q is approaching P, getting to the red line. So if you're looking at this one, with this format, X is approaching A. In other words, limit of f of x minus f of A over x minus A as X approaches A. If we are looking at this one, we take the limit of this as h approaches 0, as this distance becomes 0. Limit of f of a plus h minus f of a over h as h approaches 0. All of them are referring to the slope of a secant line. All of them are referring to the slope of a tangent line. This is also called the difference quotient. Now, f prime at a point A, limit of f of x minus f of a over x minus a as x approaches a, or limit of f of a plus h minus f of a over h as h approaches 0. When you want to write the equation of a line, standard form ax plus by equals c, point slope y minus y1 equals m times x minus x of 1. And finally, we solve for y to get to the slope intercept form, y equals mx plus b. Therefore, if you look at this pair a comma f of a, and you want the equation of a tangent line at the pair a comma f of a, we use the point slope y minus y1. That means y minus f of a equals m, which is f prime of a. F prime of a is the derivative at a specific point a, which becomes the slope of a tangent line, x minus a. In other words, You don't have to memorize that. Just follow the point slope. Now, find the derivative, aka also known as instantaneous rate of change of f of x of the function f of x equals x squared minus 8x plus 9 at a specific point x equals 5. Now, of course, we can find the general form and then change x to 5, but specifically we want to find f prime of 5 here in this example. So here's what we do. We go with the definition. One of those, you can do any of them. At some point, I will do both for practice, but this is used more often. So the limit as h approaches 0 of f of a plus h, that means we're going to write f of 5 plus h minus f of a, that means f of 5 over h. So we're going to write that because x equals 5. So let's plug in 5 plus h here. We get 5 plus h quantity squared minus 8 times 5 plus h plus 9. And let's plug in 5 minus 5 squared minus 8 times 5 plus 9. So I hope you realize, basically, you can ignore the limit, simplify this, and then plug it into the limit. But it's important you have to follow the limit eventually. So the bottom line is now we are going to simplify the numerator. So I'm going to do that. This one is 25 plus 2 times 5 times h, 10h plus h squared minus 8 times 5 is 40 minus 8h plus 9 minus this is 25, so minus 25. 8 times 5, 40 plus 40 minus 9. Rather than simplify the second parentheses, I figured if I do it this way, it's easier to, I believe it's easier to cancel things out. That's why I'm going to go with that. Also, what I used here is the identity everybody is familiar with. A plus b squared is a squared plus 2ab plus b squared. A minus b quantity squared is a squared minus 2ab plus b squared, and that's what we used here. And so what happens? 25, negative 25, negative 40, positive 40, 9, negative 9. So we have h squared at top. We have 10h and minus 8h and h squared. So 10h minus 8h is 2h. You factor the h out from the numerator. So you cancel out the h. And now, this is important. If you simplify the expression, you get 2 plus h, and that's the final answer, unless you use the limit. That's why limit of 2 plus h as h approaches 0, replace the h with 0, and you get 2. If you don't have the limit, without the limit, you can't change this to 2. Okay, so you can simplify the fraction and then write the limit of the final simplified format. You can do that. Now, of course, we could have found f prime of x and then plugged in. Don't forget that we are using definition, and some of you may know that there's an easier way of doing that. We are going to go with the definition for this exam. Find the derivative of these functions a and b, and now a general form f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0, a general form. So we're going to stick with this formula. Therefore, f prime of x would use the limit as h approaches 0, fraction bar, the bottom is h, the top is f of x plus h. So that means 5 times x plus h plus 1 minus 5x plus 1. So that would be following this definition. All you have to do is simplify. Again, I can't emphasize this enough. We are using definition. You can differentiate this stuff much faster when we go to other later sections. So 5x, 5h plus 1 minus 5x minus 1. 5x and minus 5x cancel each other. 1 and negative 1 cancel each other. So we end up with 5h in the numerator. Again, this is, of course, you cross out the h. Limit of 5 as h approaches 0 is 5. Now, this one, the limit as h approaches 0, fraction bar at the bottom is h. The numerator is f of x plus h, 2 over x plus h, minus f of x, 2 over x. So the numerator is f of x plus h minus f of x. So, of course, if you plug in, you get 0 over 0. The technique is LCD. The least common denominator, which is the product of these two, x times x plus h. So you're going to multiply the top and the bottom by. The bottom, you keep it as a product. The top, if you multiply these two, x plus h goes away, you get 2x. If you multiply this, 2x goes away, minus 2 times x plus h. So complex fraction becomes a simple fraction. So this is 2x minus 2x minus 2h. These two cancel each other. We can get rid of the h. Now this expression, if we plug in h equals 0, we get x times x plus 0, or simply x times x. So f prime of x is negative 2 over x squared. And that's the final answer, everybody. Find an equation of a tangent line to the graph of the function f of x equals square root of 3x plus 1 at x equals 8. Well, to find the equation of a tangent, equation of any line, we need a pair. Well, 8 you put in, you get the pair. And you need the slope. Therefore, you have to find f prime of x. And when you plug in, becomes a slope. In other words, f prime of 8. So let's find f prime of x using this formula. F prime of x is the limit as h approaches 0 of a fraction bar. The denominator is h. What is f of x plus h? Square root of 3 times x plus h plus 1 minus f of x, which is this expression. So this piece is f of x plus h. Clearly, if you plug in, you get 0 over 0. Because you're dealing with radicals, you multiply by its conjugate, which means you write the same thing, but you change the sign. So plus, and then you multiply and divide by. This is the conjugate of this one. A minus B, A plus B. Let me write that at the bottom, reminding you again that the conjugate of A minus B is A plus B, and the result is A squared minus B squared. Now, first, we don't touch the denominator. The numerator becomes 3 times x plus h plus 1 under the radical quantity squared. This is plus 1 minus the square root of 3x plus 1 quantity squared. Now again, The numerator, remember h is approaching 0. It is the 0 in the denominator that creates a problem. So you never ever distribute, simply you write this. So square this minus square this. So each one comes out. This simply comes out of the radical minus this one comes out of the radical. So this is 3x plus 3h plus 1 minus 3x minus 1. Just distribute. So 3x and negative 3x cancel out. 1 and negative 1 cancel out. So you have 3h. Now 3h, the h and h cancel out. So you get this one. Now, with the limit, replace the h with 0. If you do that, this becomes identical to this one. In other words, this becomes square root of 3x plus 1 as well. And therefore, f prime of x is 3 over 2 square root of 3x plus 1. Now, this is f prime of x, the derivative function. It is not the slope. What is the slope? When you plug in 8, becomes the slope. So what are we doing? When we plug in 8, first of all, if you plug in 8 here, 3 times 8, 24, and 1 is 25. So it gives you 8 comma 5 because you need a pair. Secondly, you put it here. Again, this is 5. So 3 over 2 times 5. That means 3 over 10. So we need the slope. We need the pair. How do you find the pair? Put the number into the original function. How do you find the slope? Put it into the derivative function f prime of x. Y minus y1. That means y minus 5 equals m 3 over 10, x minus x of 1, x minus 8. So distribute, you get 3/10 of x, and this one minus 24 over 10 or minus 12 over 5. So minus 24 over 10 or minus 12 over 5. You move the 5. And 5 is 25 over 5. So we get this one. And just, you can plug in 8, it should work because this pair belong to the original function. This also belongs to this one, and it does. 3 times 10, 3 times 8 is 24 over 10, or 12 over 5, which with 13 over 5 becomes 25 over 5 or 5. So that's the idea. And again, I want to emphasize, when you find the equation of a tangent line, you don't have to memorize. Let me write this. You don't have to memorize the tangent line. Y minus f of a equals m, no, f prime of a times x minus a. You don't have to, just go with the point slope. It's easier. Okay, you don't have to memorize that. It's a lot easier to go this route. All right, the graph of a function f is given in the figure. Use it to sketch the graph of the derivative. So let's see how we do that. First, if you look at peaks and valleys, those are relative extrema where f prime is 0, because if you draw a tangent line, it's horizontal. Then decreasing, increasing, decreasing, increasing. So relative max or mean is when f prime is 0. F prime is positive, that means f is increasing. F prime is negative, that means f is decreasing. So when we look at that, we have those pairs. Just to give you an idea, they correspond to, if you want to graph f prime of x, to, in this case, the x is whatever a is, same x. The y is 0, same thing. whatever B is referring to, the y0, the same thing, this one. So it's important to understand that A corresponds to A prime, same x coordinate, the y coordinate is 0, B, the same y x coordinate as B, C, the same x coordinate as C, so we're going to call it A prime, B prime, C prime. So 0, 0, 0. Those are x-intercepts. Now, if you look at this part is decreasing, so it corresponds to this part. Decreasing means f prime is negative, means below the x-axis. This portion is increasing. That means you go above the x-axis. However, it's 0 here, it's 0 here. You go up, but you have to come back at some point. We may not know exactly at what point, but the fact of the matter is this corresponds to 0, this corresponds to 0. Now, this part is also decreasing. So that means here it goes down below. But again, the reason it has to come back up because at C is 0. This is 0, this is 0, and we know this is negative. So it goes down, but it has to come back up. And over here is increasing. That means it has to come back up. I want to discuss this point, and that is the following. They pick a point and they do their best to draw a tangent line, and then they calculate by picking up a couple of points. They calculate the slope. The slope is 3/2, right? So this point, the x coordinate is 5, then m is 3/2, corresponds to the same x coordinate 5 with the slope of 3/2 or 1.5 being its y coordinate. So that's it. So a quick recap. You start with easy points. They correspond to 0, which means they will be the x-intercepts. And then you look at where the function is decreasing below the axis, increasing above the x-axis. That's all. All right, the graphs given. Use it to sketch the graph of the derivative. When you deal with a line, any line, all you have to do calculate the slope, and the value of the slope, for example, the slope is 5, y equals 5. The horizontal line is the answer. The slope is -5, y equals -5. In this case, we can calculate the slope by picking 2 points. This is located at 0, 0, and this one is located at 1, 3, because this is number 6, everybody. And so with that being the case, you calculate the slope, rise over run, 3 minus 0, 1 minus 0. And so the answer is y equals 3, which is a horizontal line. It's that simple. When you look at this graph again, look at the easy points. These 2 points correspond. So the same x coordinate, the y0, the same x coordinate, the y0. Then here, in between f prime, because this is decreasing, f prime is negative, so that means in between it has to go down. But when it goes down at this point, it has to come back up at this point. At some point, it has to come back. This is increasing, so is this one. And so this has to be above, this has to be above. And putting it together gives you this graph. What about this one? Again, let's go with this easy point. Corresponds to 0, 0. Clearly increasing. So to the left of this, above the x-axis. Decreasing means below the x-axis, and it looks like that. How can a function fail to be differentiable? Well, there are three ways for it to happen. The figure illustrates the three possibilities when we have a corner, or they call it sharp corner, when we have a discontinuity, for example, a jump, when we have a vertical tangent line. So a corner or kink, the graph of f has no tangent line at this point. The left and right limits are different. So in other words, think about this. Come up with a tangent line. How would you come up with a tangent line? That's the idea. When we have a discontinuity, if f is not continuous at A, then f is not differentiable at A. So at any discontinuity, for instance, a jump discontinuity, f fails to be differentiable. Again, where do you add, at a specific point, there should be one tangent line. Where do you put the tangent line? Now, a vertical tangent line, as you remember, a vertical line has a slope, which is, we called it undefined, but it really goes to infinity. So positive or negative infinity. That's why we have the limit of the absolute value of f prime of x as x approaches a is infinity. That means could be positive or negative infinity. The graph of a function f of x has a vertical tangent at a point a comma f of a, if and only if, this is how we read this, I with double f. The limit of f prime of x as x approaches infinity is either negative infinity or positive infinity. Both sides have the same result. So the bottom line is you have a vertical tangent line, so that's not acceptable either. But this, which looks like a sharp corner, is slightly different, is called cusp. For example, at 0 in this case, the limit of x, the limit of f prime of x as x approaches 0 from the right is infinity, but 0 from the left is negative infinity. So in essence, you have two vertical tangent lines in essence. With they are at top of each other, but they do have different uh, uh, slopes, infinity versus negative infinity. So when the graph of the function becomes vertical and then virtually doubles back on itself, such pattern signals the presence of what is known as a vertical cusp. In general, we say that the graph of f of x has a vertical cusp at the pair a comma f of a if and only if the limit of f prime of x as x approaches from the right is infinity, but from the left is negative infinity, or vice versa. Both sides do not have the same result. Over here, both sides had the same result, either negative or positive infinity, but in this case, one side is infinity and the other side is not. That's the idea. So a quick recap. It fails to be, a function fails to be differentiable if it has a sharp corner, a cusp looks like it, um, a discontinuity, or a vertical tangent line. For example, the graphs are given here, where and why the function is not differentiable. So we want to discuss those. Obviously, at 0, there's a discontinuity, or you can see a vertical asymptote. Now this one, at x equals 3, that's a vertical tangent line. One may think, okay, no, it's a sharp corner. Not the case. and I'll show you the difference in a moment, but if you think it's a sharp corner, I have no problem with that. I will show you how you can distinguish between the two. For this graph, obviously, at -1, we have a discontinuity. At 2, we have a sharp corner. Now, how do we know this is a sharp corner, this is not? I hope you recognize this. Really looks like a V shape. That's not a V shape. Or the inverted V shape. It can be like so. It can be like so also, okay? But again, let me just erase my work so you can see. This looks like a V shape, but this is not a V shape. Okay, so I think it's sort of easy to recognize the difference between the two. The graph of function f is given. Use it to sketch the graph of the derivative f prime. And so what I want you to recognize 1, 2, 3, 4 line segments. If this was just a line, then you would calculate the slope and a horizontal line would be answered, you would be done. So instead you have 1, 2, 3, 4 line segments. You will have 4 horizontal lines, but a portion of it. And everything is a sharp corner. You have a hole here, you have a hole here, you have a hole here corresponding to that. So slope is rise over run. We are going, and again, these are the numbers that I'm giving you so you calculate the slopes. It normally is more clear when you have it for your homework or exam. For example, in this case, we want to calculate the slope rise over run. This one would be 0 minus 1 over minus 1 minus 3, and the slope becomes -1/2. And I hope you recognize if this is -1/2, this one must be m equals +1/2. This you can easily see -1, 0, 0, 1. You can calculate the slope as 1, and therefore this one is m equals -1. So first and foremost, calculate all the slopes. Now, again, if you just look at this one, you need to come up with the horizontal line y equals -1/2. So y equals -1/2 would be a horizontal line like so. However, from here to here, if you look at this portion, so from here to here, we don't know what happens, then it may continue. But definitely at this end point, we should have a hole, and we do. That's it. Now you do the same thing for the rest of it. For this part, you have a hole here, you have a hole here. So you draw the line y equals 1. And for y equals 1 goes from here to here. Or y equals -1 goes from here to here. And both ends have a hole. And obviously this one, y equals 1/2, goes from here. And that's the final graph. I'm using the arrows to get help, okay? Those are not part of the graph. Find the limits. The limit of square root of 1 plus 4x to the power of 6 over 2 minus x cubed as x approaches negative infinity. And if you plug in class negative infinity to the power of 6 is positive times 4 is positive, comes out as infinity. This one x cubed is negative infinity. This makes it positive. So it's infinity over infinity. It's indeterminate. So what is the technique we are going to use? Remember, when you have a rational function, you divide by highest degree term in the denominator. And the reason this is not a rational function because the numerator has a square root. But we're going to treat it like that. And there are different techniques. For example, inside I can take out the x to the power of 6. And when I take x to the power of 6 out from the inside, this becomes 1 over x to the power of 6. This becomes 4. And I can bring this out. Now, how do I bring this out? I got to pay attention to the fact that x is approaching negative infinity. What does it mean? In case of a limit as x approaches infinity for x larger than 0. Everybody recalls that square root of x squared is not x, but it's absolute value of x. If x is approaching infinity, it's equal to x. And if x is approaching negative infinity, then it's minus x, because x itself is negative. This means the opposite of that. Therefore, this comes out as the absolute value of x cubed, and we need to figure out how to deal with that. Square root of x to the power of 6 is absolute value of x cubed. Square root of x to the power of 6 is x cubed if x is positive, and it's negative x cubed if it's negative. Since this is approaching negative infinity, then we can change this with minus x cubed. So now, of course, it's not a rational expression, as I mentioned. However, you can divide everything by x cubed. Why x cubed? This is the highest degree term in the denominator, everybody. So if that is the case, what happens? When you divide the numerator by x cubed, this goes away. This one becomes 2 over x cubed. This becomes minus 1. We are ready to plug in. If you plug in infinity or negative infinity, makes no difference. 2 over a huge number on the negative or positive side becomes 0. This becomes 0. Minus the same thing here. This becomes 0. 4 remains. As you know, minus is outside. 4 comes out as 2. So minus 2 over minus 1 is positive 2. So be very careful with the sign, everybody. So a quick recap. When you want to deal with roots, it depends on the index. When it's odd, you have no restrictions. Negative, negative comes out, positive, positive comes out. But when it's even, you want to pay attention to the fact that square root of x squared is not equal to x, but rather square root of x squared equals absolute value of x, and that will help you figure things out, as we've done it here. Okay. Now, a similar question, we want to find the limit of x squared over the square root of x squared plus 4 plus 1, where x is approaching 1. And again, reminding you that the square root of x squared is not equal to x, but rather absolute value of x. If x is approaching negative infinity, becomes negative. So we can factor x to the power of 4 out from the inside the radical. This comes out and it becomes a square root, becomes absolute value. Now, the absolute value, since x is approaching infinity, this comes out as x squared. In fact, okay, the square root of x to the power of 4 is absolute value of x squared. X squared is larger than or equal to 0. So square root of x to the power of 4 is x squared. Okay. When x is larger than 0 and square root of x to the power of 4 equals x squared, even if it's less than 0. I want to explain this one to everybody. X squared, regardless, is always positive, everybody. Therefore, because this exponent is an even one, so x to the power of 2, x to the power of 4, x to the power of 100, and they're all having exponent even, then you can drop the absolute value. Even if this was approaching negative infinity, you could drop the absolute value. Why? Because the exponent on this is positive. So it's x squared. And now we are going to cancel out the x squared from the top and the bottom. This goes away. This goes away. And this is replaced by 1. The numerator is replaced by 1. Now, if you plug in, this goes to 0. 1 over 1. 1 over square root of 1 plus 0. This is 1. And you get the answer 1. It's very straightforward. I hope everybody's okay with that. Okay. Find the derivative of the function f of x is 7x squared plus 4. Again, later on, we have formulas for it. For now, we must use definition. So we use this definition. F prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. So the limit as h approaches 0, fraction bar. The bottom is h. What is f of x plus h? 7 times x plus h quantity squared plus 4 minus f of x. All we have to do is simplify the numerator. So this is x squared plus 2xh plus h squared. You distribute the 7, you get 7x squared plus 14xh plus 7h squared minus plus 4 minus 7x squared minus 4. Seven x squared minus 7x squared cancel each other. So do 4 and negative 4. We are left with this piece. As you can see, we can take 7h out, but I'm interested in getting rid of the h. So I'm going to take the h out only. This is not a proper factoring class. And I did that because I just want to get rid of the h. You can do it either way. And so we get the limit of 14x plus 7h as h approaches 0, which means now you can replace this and you get 14x. And again, later on when we use the formula, we get to the answer in a split second. For now, we must use definition for this exam. The distance in feet of an object from a starting point is given by s of t equals 2t squared minus 5t plus 4, where t is time in seconds. What is the average velocity of the object from 2 to 4 seconds? First, reminding you the average velocity, basically when you have 2 points given, is just rise over run. The total distance over the total time gives you the average speed or velocity, which means the average is s of t sub 2 minus s of t sub 1 over t sub 2 minus 1. So of course, this is 4 minus 2. This one is s of 4 minus s of 2. This is elementary algebra. So plug in 4, plug in 2. When you plug in 4, 2 times 4 is squared minus 5 times 4 plus 4d. When you plug in 2, 2 times 2 is squared minus 5 times 2 plus 4. So 16, 32 minus 20 plus 40. That is 52. This is 4. Makes it 8 minus 10 plus 40, which is 38. So minus 38. And it becomes 14 halves or 7 feet per second units of the numerator over units of the denominator. Now, what is the instantaneous velocity of the object at 4 seconds? Even if they don't mention instantaneous, even if they don't mention average. If you're given 2 points, it's average. If you're given 1 point, it's instantaneous. We simply put means take the derivative. So we're going to go with this definition. The limit of, remember, it was f of a plus h minus f of a over h. Now we're going to go with s because it's the s function. And you can find the derivative and then plug in number 4, or just find it in this format. So s of a plus h, that means s of 4 plus h minus s of 4. So s of 4 plus h, let's plug it in here. 2 times 4 plus h squared minus 5 times 4 plus h plus 40. And then s of 4, you can even use the fact that s of 4 we calculated to be 52. You can write this or just a 52. So I'm using 52 because we've already done that. As you know, 4 plus h squared, you square this one is 16. 2 times this times that plus 8h plus h squared. Now we're going to distribute the 2. We get 32 plus 16h plus 2h squared minus 20 minus 5h plus 40 minus 52. And again, this 52, we had calculated it here, so we didn't repeat that. We didn't have to. $32 with 40, 72 with negative 20 with minus 52, they cancel each other. So we have 2h squared plus 11h because 16h and minus 5h, they add up. So take the h out, drop it, plug in 0, and you get 11 feet per second. By the way, the units, it's very straightforward, everybody. This one is really the SDT, the units. This one is the change, the units of the numerator over the units of the denominator. Same thing here, and you end up with the same unit, feet per second. Finally, equation of a tangent line to the parabola y equals x squared at the point 1, 1. And what I want to do, again, there are two ways. You can calculate the derivative and then plug in the x coordinate 1, a equals 1 at the end. But for practice, I want to find f prime of a, and I'm going to find it two different ways, just for practice, as it was promised before. So here you have a equals the x coordinate of the pair, a equals 1. The function is x squared. So we are going to go with one of those. For example, if I go with the limit of f of x minus f of a over x minus a as x approaches a, because sometimes one may be easier than the other. So we will do both for practice, everybody. So f of x minus f of a is 1. The limit of f of x minus f of 1 over x minus 1 as x approaches 1. Replace the f of x with x squared. F of 1 is, you already have it, or plug it in. And if you plug in, you get 0 over 0. The technique is factoring, reminding you of all of those. Okay, for example, this one is a squared minus b squared, x squared minus 1 squared, a minus b, a plus b. This is x minus 1, x plus 1. So it's the limit of x plus 1 as x approaches 1, and now you plug in, you get 2. Now, of course, y minus y1 equals m times x minus x of 1, which means y minus 1 equals m2 times x minus 1. Y equals 2x minus 1. We are done. But I just want to quickly remind you of the second method for finding this slope. So I'm going to find this slope, and I'm going to replace the a with 1, of course. So f of 1 plus h minus f of 1 over h, we're going to take a limit as h approaches 0. So into x squared, we're going to put 1 plus h quantity squared. And then that part, we already know the answers. So if you square that using the identities, you get 1 plus 2h plus h squared. 1 and negative 1 cancel each other. Factor the h out. Drop the h from the top and the bottom. And now if you plug in, you get the same 2. And that's the idea, class. You get the same 2. Now, of course, I'm not going to go through that process, but you get the picture. My point being, there are two ways to calculate f prime of a. Either way is fine. This is normally more often used. We use f prime of x is f of x plus h minus f of x over h as h approaches 0. Find an equation of a tangent line to the graph of this function f of x equals square root of x at the given pair. By the way, they don't have to give you both x and y. If they give you x, that's good enough, because square root of 16 is 4. You should recognize that. So you want to find the equation of a tangent line, so you have to differentiate this. Again, we are going to use one of those definitions. Okay, a is 16 f of x squared of x, and here's the definition we are going to use. In fact, I'm going to use both again for practice, everybody. So what is f of a plus h? So the limit as h approaches 0, the denominator is h, the numerator is square root of x plus h. That means f of 16. So replace the a with 16, and then square root of 16 plus h minus square root of 16 over h. Now, square root of 16 is 4. So you can put the 4 here. But the reason I want to go with the square root of 16, what if it's not a perfect square, it doesn't come out? I want to show you the process in the same manner. And so if you plug in, you get 0 over 0. You have square roots. The methodology is to multiply by the conjugate. Remember, a minus b, the conjugate is a plus b. So multiply by the same thing with the plus sign and divide by it. This is 0 over 0. If you plug in, you have to go with this route. So you change the minus to plus. And the reason you put it at top as well as the bottom, because this expression is 1, and therefore it's okay. When you multiply these two, the denominator, you just write it as it's given. The numerator is a squared minus b squared. So everything comes out. 16, negative 16 cancel each other. H and H cancel each other. We have this. Now there is no more step to simplify this. Now you plug in. If I plug in 0, I get 4 here, I get 4 here, I get 1 over 8. And that's the idea, everybody. y minus y1 equals m times x minus x of 1. That means y minus 4 is 1 over 8x minus 16. And of course, you distribute 1 over 8x minus 16 over 8 or 2. You move the negative 4. Okay, becomes positive 4. This is the answer. And by the way, class, you can check it out. If you plug in 16, you get 4. You're done. However, I want to find the slope using this formula just for practice. So you're exposed to both of them. So m equals f prime of 16. The limit of f of x minus f of 16 over x minus 16 as x approaches 16. Plug in, you get 0 over 0. F of x square root of x minus f of 16 is 4, and the bottom is x minus 16. X approaches 16. If you plug in, you get 0 over 0. What is the technique? You have a square root. So the technique is conjugate. What is the conjugate of the numerator? Square root of x plus 4. Multiply and divide by it. Again, just like this was equal to 1, this is equal to 1, so this is acceptable. What happens to the bottom? Absolutely nothing. Keep it as a product. What happens to the numerator? You square each piece. So it becomes x minus 16. X minus 16 cancels out x minus 16 in the denominator. And now, if you plug in, you get 4 and 4, 8. The answer is 1 over 8. That's how you find the slope, the second method. And of course, y minus y1 equals m times x minus x of 1. You can find the equation of a tangent line accordingly.